What is an air compressor? Compression is a process of increasing the pressure of any state of matter. Air compression is the process of increasing the air pressure above the atmospheric pressure. The mechanical device used to compress air is called an air compressor. Thus, the air compressor is a mechanical pneumatic device powered by IC engines or electric motors to convert the kinetic energy of air to potential energy. The compressed air from the air compressors is usually stored in a high pressure vessel. An example is shown in the image below. Every air compressor follows and obeys Boyle's law. The product of pressure and volume of the mass of a confined gas is constant and proportional to the temperature. Compressors, such as piston cylinder systems and other types, are devices that absorb work to increase air pressure. Their operation follows these steps. First, the compressor draws in air from the atmosphere. Second, a working component, like a piston, compresses the air, reducing its volume and increasing its pressure. Third, according to Boyle's law, this compression also raises the air's temperature. And lastly, fourth, the high pressure air is then delivered to a storage vessel where it is kept as potential energy for later use. There are multiple types of compressors. These are some of them. First is the reciprocating compressor. It uses pistons to compress air, ideal for high pressure applications. Next is the rotary screw compressor. It uses twin screws for continuous compression. It is efficient for industrial use. Centrifugal compressor. It uses high-speed impellers to generate compressed air. It is best for large volumes. And lastly is the axial compressor. It uses rotating blades to compress air. It's common in jet engines. Single-stage compressor. The area under the figure shows the work done in compressing the air to P2 from P1, and the line with the least slope produces minimum or lowest work. As seen from the graph, isothermal compression produces minimum work, and it is the condition under which minimum work can be achieved in a compressor. Now for the formulas. First is the piston displacement. Piston displacement is the volume displaced by the piston as it moves from top dead center to bottom dead center. For the formula, Vd, which is volume displacement, is equals to pi times the diameter squared over 4 multiplied to the stroke or the length times the speed times the number of cylinder and times the number of piston action. Then, for the piston displacement of a double-acting single-stage compressor, first is if piston rod is neglected. The volume displacement is equals to pi times the diameter squared times the length times the speed over 2. Next is if piston rod is considered. The volume displacement is equals to pi diameter squared over 4 times the length times the speed minus pi the diameter squared over 4 times length times the speed. Volumetric efficiency. Volumetric efficiency is the ratio of the actual gas drawn in at intake condition to the displacement volume or the piston displacement. For the formula, volumetric efficiency can also be 1 plus clearance minus the clearance multiplied by P2 over P1 raised to 1 over n. Then, for the actual volumetric efficiency. The actual volumetric efficiency is usually less than the clearance volumetric efficiency because of the number of factors, such as pressure drop at the valves, heat transfer between surrounding and device, and the presence of residual gas in the cylinder at the end of the delivery stroke. For its formula, it is the clearance volumetric efficiency multiplied by P1 over the atmospheric pressure times the atmospheric temperature over T1. Capacity of compressor. The capacity of compressor is the actual volume of gas delivered as measured at intake pressure and temperature. For the formula, V1 is equals to MRT over P. For the polytropic compression, this process lies between the isothermal and isentropic processes. In the figure, 1 to 2p is a polytropic process, and the relationship between pressure and volume is given as PV raised to n is equals to C. Also, the work done during the polytropic process is given as work is equals to n P1 V1 over n minus 1 multiplied to P2 over P1 raised to n minus 1 over n minus 1, or work is equals to n MRT1 over n minus 1 multiplied by P2 over P1 raised to n minus 1 over n minus 1. Isentropic compression. The isentropic process is a reversible adiabatic process where there is no heat exchange and no entropy is generated. So the work done during the isentropic compression is calculated using work is equals to K P1 V1 over K minus 1 multiplied by P2 over P1 raised to K minus 1 over K minus 1. Or work is equals to K MRT1 over K minus 1 multiplied by P2 over P1 raised to K minus 1 over K minus 1. Isothermal compression. Isothermal compression takes place at constant temperature. Work done during an isothermal compression is evaluated as work is equals to P1 V1 times the natural logarithm of P2 over P1, or work is equals to MRT1 times the natural logarithm of P2 over P1. So for the compressor efficiency is the ratio of the compressor power to the brake power. Next is the piston speed. Piston speed is the total distance a piston travels in a given time. It depends on the length of stroke and the angular speed. Lastly is the ideal indicated power. Ideal indicated power is the product of the indicated mean effective pressure and displacement volume. For a two-stage reciprocating compressor with complete or perfect intercooling, work done is given as work is equal to 2n P1 V1 over n minus 1 multiplied by Px over P1 raised to n minus 1 over n minus 1. Next is the intercooler pressure. For minimum work condition with perfect intercooling to be obtained, the intercooler pressure is evaluated as Px is equals to the square root of the product of P1 and P2. Then, for the heat rejected in the intercooler, so the rate of heat rejected in the intercooler in kilogram per second is given as Q, which is the heat rejected, is equals to the mass flow rate multiplied by the specific heat at constant pressure times the Tx minus T1. Then lastly is the intercooler temperature. For complete or perfect intercooling in a two-stage reciprocating air compressor, the intercooler temperature, also known as the intermediate temperature, is given as Tx is equals to T1 multiplied by Px over P1 raised to n minus 1 over n. For the first sample problem, is a two-stage compressor has a suction pressure of 14 psi and discharge pressure of 130 gauge pressure in psi. What is the intercooler pressure in gauge pressure in kilopascal? So let's find the given. So the first pressure is 14 psi, while the third pressure is 130 gauge pressure in psi, and we have to find the second pressure. So to find the second pressure, we have to use the formula P2 is equals to the square root of the product of the first pressure and the third pressure. So before we can substitute the given to the formula, as you can see, the first pressure and the third pressure have a different measurement. The first pressure is in PSI, while the third pressure is in PSI gauge. So we can turn the PSI gauge to PSI absolute by adding the PSIG to the atmospheric pressure. So 130 PSIG plus 14.7 PSI turns it into 144.7 PSI atmosphere. So now we can substitute this given to the formula. So after we substitute it, we get the product 45.0089 psia. Since we have to find the second pressure in kilopascal gauge, we have to turn back the psia to psig by now subtracting the atmospheric pressure. But so after subtracting 14.7 psi, we get 30.3089 psig. So now to convert psig to kilopascal gauge, we have to multiply it by 6.895 kilopascal gauge, getting the second pressure 408.9799 kilopascal gauge. Now for the second sample problem. An air compressor takes air at 97 kilopascal at the rate of zero point 0.5 cubic meter per second and a discharge of 500 kilopascal. If power input to the compressor is 120 kilowatts, determine the heat loss in the compressor. Now for the given. The first pressure is 97 kilopascal, while the first velocity is zero point 0.5 cubic meter per second, and the second pressure is 500 kilopascal, while the work is 120 kilowatts. We have to find the heat loss in the compressor. So for us to find the heat loss in the compressor, we have to use the formula for the work for polytropic compression, since this problem is a polytropic process. So for the formula, its work is equals to n P1V1 over n minus 1 times P2 over P1 raised to n minus 1 over n minus 1. So now we can substitute the given to the formula. N, in this case, n is equals to 1.4. So after substituting all the given, we can now get the final work output, which is 101.4533 kilowatts. Hence, we are to determine the heat loss of the compressor, and we are given the power input of the compressor. We can now subtract the work that we had just gotten to the power input that was given to us, which is 120 kilowatts. So now for the heat loss, we get 18.5467 kilowatts.
So for the next sample problem, the suction condition of an air compressor is 98 kilopascal, 27 degrees Celsius and zero point 0.2 cubic meter per second. If surrounding air is 100 kilopascal, 20 degrees Celsius, determine the free air capacity in cubic meter per second. So first thing to do is to list down the given. For the pressure 1, or pressure of point 1 is 98 kilopascal, volume 1 is zero point 0.2 cubic meter per second, and the temperature is 27 degrees Celsius. And next one is the if surrounding air daw is 100 kilopascal, which is that is T2, 20 degrees Celsius, and P2 is 100 kilopascal. And then find is determine the free air capacity. When we say capacity is V2 or volume 2 kasi free air capacity siya. Okay. So, ang gagamitin nating formula dito is itong P2V2 over T2 is equals to P1V1 over T1. And then, ilagay lang natin yung mga given which is P2 as 100 kilopascal and then V2 yung hinahanap and then over T2 na 20 degrees Celsius and then gagawin ng Kelvin plus 273. And then is equals to P1 of 98 kilopascal and V1 of zero point 0.2 cubic meter per second over T1 na 27 degrees Celsius plus 273 Kelvin. And then magiging Kelvin yun. So pag kinompute mo siya sa calcu, ang lalabas na V2 is 0.1914 cubic meter per second. So, iyon yung free air capacity nitong sample problem. Okay, next. An air compressor takes air 100 kilopascal and discharge to 600 kilopascal. If the volume flow of discharge is 1.2 cubic meter per second, determine the capacity of the compressor. And then for the given, P1 which is 100 kilopascal, P2 is equals to 600 kilopascal, and then the volume flow of discharge which is V2 kasi discharge siya is 1.2 cubic meter per second. And then ang standard ng air is 1.4. So, ang pinapahanap dito is determine the capacity of the compressor which is yung V1. Okay, para makakuha natin yung V1, we can use this formula. P1 V1 raised to N is equals to P2 V2 raised to N. Then just substituting the given. P1 is 100 and then V1 na yung hinahanap mo, and then N of 1.4 is equals to P2 which is 600 kilopascal times V2 na 1.2 cubic meter per second, and then N na 1.4. So, cancel lang naman yung kPa, and then matitira is cubic meter per second. And then, if i-compute mo sa calcu, in-input mo, ang magiging sagot is 4.315 cubic meter per second. The piston displacement of a double-acting compressor is 0.358 cubic meter per second. Delivers gas from 101.325 kilopascal to 675 kPa at the rate of 0.166 cubic meter per second at 150 RPM. Value of N for compression and expansion is 1.33. Find the bore and stroke assuming bore is equals to stroke. So again, let's list down the given first. For the V1, VD, piston displacement of a double acting compressor, which is 0.358 cubic meter per second. Then sabi, delivers gas from 101.325 kPa. So that is P1 to 675 kPa, which is P2. And then at the rate of 0.166 cubic meter per second at 150 RPM, which is 150 RPM mo is N. So, dito, kanina kasi, standard air is 1.4 pag walang sinabi. Pero since dito nagkaroon or sinabi sa problem ang value ng N, we will use this as 1.33. So, ang pinapahanap is bore and stroke. Since ina-assume mo na bore is equal lang siya sa stroke, which is D is equals to L ang hinahanap. So by that, we can use this formula as formula ng volume displacement is equals to 2 times pi over 4 D squared L times N. So, yun nga, meron na tayong given na VD, may ang D squared is hinahanap, and then D is equals to L nga, and then N is given. Ang VD mo is 0.358 cubic meter per second, and then 2 times pi over 4. So, equals na natin tong L as D. So, ayan, D squared. And then D. And then N is 150 per minute yan pag RPM. And then, i-convert lang natin into second, kaya may over 60 second dyan. So, if we compute this, we will get the D as 0.45 meter. And then, convert lang natin into mm, which is 450 millimeter. So, D is equals to L is 450 millimeter.
So, another problem. An air compressor has a suction volume of 0.25 cubic meter per second at 97 kPa and discharges to 650 kPa. How much power is saved by the compressor if there are two stages? So, ang unahin natin ay yung pagkuha ng given. Ang una nating given ay volume flow rate which is 0.25 cubic meter per second. Ang pangalawa is ang una nating pressure or yung suction pressure at 97 kPa. At yung discharge pressure natin is or P2 is 650 kPa. Kung hindi given ng K, ito ay equal to 1.4. So, ang hinahanap ay ang save na power. So, mostly kilowatt ang hinahanap na unit niyan. So, sa solution natin for single stage, gamitin natin ang formulang to. Tapos direct substitution lang ng value natin. Magkakaroon tayo ng sa unit analysis natin after yung substitution ng mga given, magkakancel yung cubic meter per second sa meter squared nung kPa natin. So, ang matitirang unit is kilonewton meter per second or kilojoule per second or kilowatt. So, ang makuha natin for single stage is 61.2822 kilowatt. So, for double stage naman, gagamitin natin ang pressure 1 and pressure 2. So, ang formula is square root ng P1 multiplied by P2. So, gamitin yung formula na yan, substitution ng value. Ang makukuha natin is 251.097 kilonewton meter squared or kPa. Next naman, kukunin natin yung work. Ang pinagkaiba lang nito doon sa naunang formula natin, dahil ito ay double stage, multiply lang natin siya ng 2. So, same pa rin siya. Input lang ng given. Substitution sa ating formula, makukuha natin ang sagot na 53.0063. So, for the last part, para makuha natin yung how much power is saved by the compressor, pag kukunin lang natin yung difference between single and double stage. So, pagmaminusin lang natin sila. So, 61.2822 minus 53.0062 kilowatt. Ang makukuha natin ay 8.276 ang final answer for this problem. So, this time, the discharge pressure of an air compressor is 5 times the suction pressure. If volume flow at suction is 0.1 cubic meter per second, what is compressor power assuming K is equal to 1.35 and suction pressure is 98 kPa? So, tulad kanina, unahin natin pag-identify ng given. So, ang volume flow rate natin sa given is 0.1 cubic meter per second. And assuming K is equal to 1.35 and suction pressure or pressure 1 is 98 kPa. Ang pressure 2 natin or discharge pressure is 5 times the suction pressure or P1. So, makukuha natin siya pag multiply natin yung P1 sa 5. So, P2 is equal to 5 times 98 kPa is equal to 490 kPa. So, ang hinahanap lang is yung work ulit or compressor power. So, single stage siya. Gamitin lang ulit natin yung ginamit natin na formula kanina. So, direct substitution lang siya ulit. Input lang ulit tayo ng given. Makuha natin to. So, unit analysis ulit. Ang matitira is kilonewton meter per second or kilojoule per second or kilowatt, which is equal to 19.5728 kilowatt. So, for the last problem of this topic, a two-stage air compressor has an intercooler pressure of 3 kg per cubic centimeter. What is the discharge pressure if the suction pressure is 1 kg per centimeter squared? So, tulad lang ulit ng kanina, kung i-identify lang ulit natin yung mga given. So, ang P1 natin is equal to 1 kilogram per centimeter squared. At yung ating intercooler pressure is equal to 3 kilogram per cubic centimeter. So, ang hinahanap natin is P2. Ang gagamitin lang natin formula is yung tulad ng ginamit natin kanina, which is equal to Px is equal to square root of P1 multiplied by P2. I-derive lang natin siya ng konti. So, P2 is equal to Px squared over P1. Ang kakalabasan ng formula na gagamitin natin. So, input lang ulit natin yung given. 3 kilogram per centimeter cube squared siya over 1 kilogram centimeter squared. So, ang kakalabasan niya is 9 kilogram per centimeter squared. Then, convert lang natin siya sa kPa, which is multiply lang natin siya sa 98.066. Ang makuha nating value ay 882.594 kPa ang ating discharge pressure. Yun lang po. Marami pong salamat.